Hi everyone, I'm Zhi Huang, and my talk today is Visual Language Foundation Model for Pathology. So machine learning needs data, but compared to other machine learning and AI data sets, which typically has more than millions or even billions of data, computational pathology faces a barrier that we're really have a limited number of annotated data set, especially with natural language description, right? But at the same time, there are tremendous amount of knowledge shared by thousands of clinicians over the public forums, such as medical Twitters. So in this study, we create open paths from Twitter and other public sources by leveraging US CAP, suggested 32 different pathology hashtags. We followed a stringent cohort inclusion and exclusion criteria by removing the text not written in English and so forth. In addition, we also added the reply with the most likes. We also removed those texts with question marks and follow with additional text cleaning, such as the removal of emoji and hyperlinks. And in addition, since not all images on the Twitter with pathology hashtag are actually pathology images, so we further train a pathology image classifier to remove those non-pathology images, such as selfies or conference photos, right? So at the end of the day, we curated 16 years of public knowledge, which contains 208,000 high-quality image text pairs. By the time we published this work, it was the largest public pathology visual language data set. And so we leveraged this OpenPath data set to train our general purpose foundation model by fitting the text into the clip text transformer and fitting the image into the image transformer and learn the cosine similarity. And we built this model called PLIP, which stands for Pathology Language Image Pre-training Model. And so PLIP is a foundation model that can do a lot of downstream tasks. One of the most exciting tasks is it is the preferred model for classification. So let's take an example in this transfer learning task. We found PLIP can outperform the same model architecture, vision transformer base, which was pre-trained on ImageNet across 4 external validation datasets, all suggesting improved performances in classification tasks. And improvement is especially large when we only use 1% of the training data. So what does that mean to us? It means that in the future, if we want to train a pathology classifier for image patch, it is better to use PLIP image encoder rather than using other model architectures. And PLIP is also the state-of-the-art image retrieval algorithm. So we conducted text-to-image retrieval and image-to-image retrieval. And here's our 2 examples. So for text-to-image retrieval, if the user input a prompt such as breast tumor surrounded by fat, it will give you the correct answer. And if the user also input an image enriched with mitosis, it will also capture the key concept of the input image and returns you the similar match. This is going to be extremely useful, especially for non-pathologists such as me to learn pathology images, right? So since release, the PLIP model has more than 100,000 downloads at Hugging Face. And what's next? So we are working on a large language model called ChatPLIT. So with that, it can answer basic pathology questions such as number of cells in your input image. And if the user asks, what is the likely diagnosis if it's from breast tissue, it will also give you the correct answer, which is PASH. So for that, I would like to thank our project teammates and our amazing advisors, Tom and James. Thank you.
Okay, well, thank you.